So there's actually no new math in this lesson. We're just using proportions and using similar triangles to solve real life type problems. So when we do that, we're going to use what's called indirect measurement, where you can find distances using similar triangles. You're measuring indirectly because probably the thing that you're trying to measure is either too big to use like a tape measure, or maybe if you're trying to measure the width of the Grand Canyon, it'll be, number one, it's too big. Number two, unless you can fly, it'd be really hard to carry a tape measure across the Grand Canyon and see how wide it is. So you can measure it indirectly using shadows and similar triangles and things like that. So let's take a look at some of these problems. You can find the height of a tree by measuring its shadow. As long as you do it at the same time of day, the sun's going to hit everything at the same angle. So you're going to have similar triangles because the sun will hit it at the same angle, and usually objects, trees and such, are perpendicular to the ground. So that would be similar triangles because they are angle. So if you can measure the length of a shadow, that's easy to do because it's on the ground. It's harder to measure vertical. You could find out what the height is by setting up similar triangles. So you hold your meter stick vertically. Obviously, a meter stick has got a length of 1 meter. The shadow is 1.6 meters. We can find the height of the tree if we measured out that the shadow was 7.2. We just set up the proportion, cross multiply, and solve. The triangles are similar. We just said angle. So we can try to find the height of the tree. We can do 1 over x equals 1.6 corresponding side over corresponding side. In this case, we did height to height and shadow to shadow. So then you cross multiply, you get 7.2 equals 1.6x. And then 7.2 divided by 1.6 is 4.5. So x is 4.5. Since that was the height of the tree, we should say that the height of the tree is 4.5 meters. Just put the units back on there. They don't really get any more difficult or even much different than that. So if Sid is 72 inches tall, we're going to measure the flagpole by standing near the flag and then measure the length of their shadow and the length of the flagpole shadow. So if we're trying to find the height, since the sun is hitting them at the same time of day, the angles will be the same. So it's angle similarity, which means we can set up the proportion corresponding side. So let's take 72 over h equals 48 over 128. Then you cross multiply. So 72 times 128 is 9,216. And then divide by 48, you get 192. And that was, the problem's all in inches, so that's 192 inches for the flagpole. If you wanted to, you could actually convert that to feet by dividing by 12. It would be 16 feet, which sounds about right. Pretty much the same problem going here. Somebody stands, they're 6 feet tall, they have an 8-foot shadow. And then the tree, we don't know the height, but it has a 28-foot shadow. So you set up your proportion, 6 over h equals shadow over shadow. Six times 28 is 168, equals 8h. And we get the height is 21. Since we're measuring in feet, that's 21 feet. So this problem just goes through a different way that you can do it. This would be kind of similar to what I was talking about for measuring distance across the Grand Canyon. A hiker wants to find the distance across a canyon, so they locate a point as described. They identify X, place a marker Y directly across the canyon from it, and then turns 90 degrees away and walks 400 feet. And they place another marker Z. So they said turns 90 degrees, so we have the 90-degree angle down there. She continues walking another 600 feet and places another marker W, then turns 90 degrees away and walks until there's a straight line with Z and X, and they put a marker V down there. And then she also measured how far she walked from W to V, 327 feet. So we are trying to find the distance across the canyon D. Now these triangles are similar because if you look at the way she did this, 90 degrees and 90 degrees plus vertical angles right there. And the triangles are similar. You can set the proportion. We could take the 327 feet, that would correspond with D. And then the 600 feet would correspond with 400 feet. If you don't like working with large numbers, you can reduce this first. 600 over 400 could easily reduce to just 6 over 4, and the numbers are a lot smaller. So 6D equals 4 times 327 is 1,308. Divide by 6 and you get 218. So the canyon is 218, it's all measured in feet, 218 feet. So here's another problem. Pretty much the same process was done to get the measurement. The triangles are similar. We've got 90 degrees, and vertical angles. So the triangles are similar. We set up the ratio. This time let's take D first. That corresponds with the 35 over there. And then the 24 corresponds with 42. So cross multiply, we get 42D equals 35 times 24 is 840. And then divide by 42. So you get D is 20. This was measured in meters, so 20 meters. Again, the same kind of process was done. We do have similar triangles because of angle. So we set up the proportion D over 12 equals 12 over 6. So 6D equals 144. 144 divided by 6 is 24. So the distance there is 24 meters.